Howdy, y'all. This is Dynamics Worksheet number 2, question number 2, that we're going to work together real quick. In this particular question, I've got a 140 Newton bucket that's being pulled directly upward by an ideal spring, a spring constant 800 newtons per meter, which as a result causes the bucket to have a downward acceleration of 2 meters per second squared. Our job is to find the stretch of the spring that's pulling the bucket upward. First thing off the bat, it's really important to notice the directions. When I draw my free body diagram, I'm going to start out by drawing gravity going down. Bucket's obviously got weight. And then I'm going to draw a spring force pulling it upwards because we're told it's pulled upward by a spring. Now I'm going to draw the spring smaller than the gravitational force because this thing has a downward acceleration. That means that the net force is down. So even though the spring is pulling upwards, gravity is pulling down with more force. So as a result, this thing is going to accelerate downward. When I write my net force equation, I have a choice as to which direction to make positive. In order to keep everything as simple as possible, I prefer to keep the direction of the net force as the positive direction. So when I write my net force equation, anything that is down, I'm going to make positive, and anything that is up, I'm going to make negative. And so that's why my net force equation is Fg minus Fs. That way, the bigger numbers have a positive sign. Just makes my math a little bit easier. The next thing I have to realize is that I don't know how big the net force is. I need that in order to find the force due to the spring. So I can use Newton's second law and solve that for the net force acting on the object. And then from there, I could solve for the force that the spring exerts. The problem is I don't know what the mass is right now, but since I have the weight of the bucket, newtons is a measure of force, so the 140 newtons is telling me the force of gravity or the weight, then I could take the equation for the force of gravity, just m times g, and I can solve it for m. Just divide the 140 newton weight of the bucket by 10 newtons per kilogram, and that tells me that my bucket's got a mass of 14 kilograms. So now I know that the mass is 14 kilograms. I know the acceleration is 2 meters per second squared. I get that the net force acting on the bucket is 28 newtons. Again, pay attention to the direction. That net force is down. So in my net force equation, anything that's down is going to be positive. So the net force in the y direction right here in my net force equation has a positive value at this point. So solving for the force that the spring exerts, when you're solving for a negative like that, I would just add it to both sides first and then isolate everything else over on the right side. It's the least likely way to cause a mistake. And so I know that the weight is 140 newtons. I know that the net force is 28 newtons, and so I subtract those, and I get 112 newtons. Now here's a point where you can stop and check yourself. The net force is downward, meaning that the force of gravity should be larger than the spring force. And so if you go back and you compare those two values, the 140 newton weight versus the 112 newton spring force, you can see that that is the case. That the spring force is smaller than the weight, which means we've probably done everything correctly. If I were to get a spring force that was larger than 140 newtons, then I've made a sign mistake somewhere, and that's probably something that I could really easily fix. So that's something that we could easily stop and check and make sure that our answer is reasonable before proceeding. That force should be smaller than the weight. It is. I'm probably on the right track so far. The next step is just to use Hooke's law. Force due to a spring equals k times x. I could solve that for x, the stretch in the spring. I've calculated the spring force to be 112 newtons. I'm given a spring constant of 800 newtons per meter, sorry. The newtons cancel out when I do the division, and I would get 0.14. Pay close attention to the units. That's meters right now. If I wanted it to be in centimeters, I could easily convert it to centimeters. That was a fun and interesting problem. Until next time, ta-ta.